Assalamu alaikum to everyone. Once again, we are starting our online lectures. Now, although this is unfortunate that we are not able to start our regular classwork, but as long as this is not over, that is the pandemic is not over, we must keep ourselves busy with this online learning mode. So from today, we are starting the online classes for both the semesters, second as well as the fourth semester. The courses has been assigned to different teachers and they will take up their own courses. So from today, I am starting a new course, that is the chromatographic technique. Now this encompasses the large number of separation techniques such as ion exchange chromatography, size exclusion chromatography, HPLC, GC, thin layer chromatography, which have the same basic principle. That is, the principle of these techniques will be same, and they are all clubbed into the chromatographic techniques. So chromatographic technique is basically a separation technique which involves the different techniques. Then, for example, it involves the thin layer chromatography, which is the type of the planar chromatography, where there's a separation of the components on a solid adsorbent. Then we have a size exclusion chromatography, where the difference in size matters. That is, if you have different molecules with different size, then the separation can take place. Ion exchange is again a chromatographic technique, but here the separation is on the basis of charge. Then we have the high performance liquid chromatography, an improved version of all these chromatography by using the high pressure to improve the performance. That is, pressure pump is used, reservoir is used, and more importantly is an automated one, and the separation is very fast. Then we have the gas chromatography, where the phase, that is the mobile phase, is a gas. So all these techniques are encompassed in one unit, that is the chromatographic techniques, which have the different principles of operating, but the basic principle will be the same for all these chromatographic techniques. So as I said, that the chromatography is a separation technique. So we have the different separation techniques. We have distillation, we have fractional distillation, we have crystallization, we have fractional crystallization, filtration is there, electrophoresis is there, centrifugation is there. Now, all these techniques, you can see that they use the different parameters for the separation. For example, distillation use the difference in boiling point. Similarly, filtration use the difference in solubility. Electrophoresis use the difference in electric charge. Centrifugation use the difference in mass and density. So they can exploit the different properties of the sample, and on the basis of that, you have the different separation techniques. For example, you have a distillation. In that is the difference in boiling point is should be there. For example, if you have a molecule like hexane and diethyl ether, which have the difference in their boiling point, while as hexane has a 60-degree boiling point compared to that of the diethyl ether, which has a boiling point of around 35 degrees centigrade. Now, if you heat the mixture of this hexane and diethyl ether at 40 degrees centigrade, you can find out that the diethyl ether distills out and you get the purified form of diethyl ether. So it is the separation on the basis of boiling point. Similarly, a simple example of the filtration is that you have the sugar or salt with impurities like sand or anything which is not soluble in the water. So you can filter them by because of their difference in solubility, and you can separate out. So the important thing is that different techniques exploit the different properties to bring out the separation. But what is different in chromatography is that it exploits different properties. It is not a single property on which it is based. That is, the chromatography can use the size, chromatography can use the charge, chromatography can use the polarity, it can use the difference in temperature, it can use the mobile phase concentration, it can even use the different stationary phases. So you have the so many availabilities, so many possibilities to bring out the separation of the complex mixtures. That is, even the optical isomers can be used, can be separated out by using the chiral chromatography, which are not possible to separate by any other method. You can use the color chromatography to separate the optical isomers. Such a beauty of the chromatographic technique appears because there are the large number of parameters that can be varied. You can vary the size, you can vary the charge, you can have the polarity, temperature. That makes the chromatographic technique a versatile technique in a separation among the separation techniques, because you have the large number of possibilities to have a separation, better separation. The chromatography improves, it reduces the interference, it purifies the compound, it isolates the compound, it can refine the compound. So these are all the properties of the separation techniques in general, but chromatography is nowadays more used because of its advantage over the other separation techniques, because as I told you that it can use the different parameters for the separation of the mixture of the components. By definition, if we go, आपकी जो chromatographic technique होती है, it is a separation of the mixture of components between the two phases where we have a one phase that is called as the stationary phase and the other one we call as a mobile phase. आपके पास दो phases होते हैं, stationary phase होता है, एक mobile phase होता है, उनके बीच में ये separation होता है, and this separation is basically based on their relative affinities with that of an adsorbent, that is the stationary phase, and that of an mobile phase. Now, on the base of that, the separation can take place. So basically, chromatography is a separation of the component of mixtures between the two phases, where one phase is the stationary phase, which can be solid, which can be liquid, supported on a solid, or which can be gel. And then you have a mobile phase, which can be liquid, which can be gas, or which can be a supercritical fluid. So you have the two different phases. One acts as a stationary phase, other acts as a mobile phase, and between them there is a separation of the mixture of components, which is based on their relative affinities with that of the stationary phase or with that of the mobile phase. So the principle is the separation of mixture of the components on the two phases, which can be bring out either on a column or which can be bring on a plane. सो क्रोमेटोग्राफी क्लासिफिकेशन जब हम करते हैं, क्योंकि हमने कहा कि क्रोमेटोग्राफिक टेक्निक जो है बहुत सारी है, because of the reason that it can utilize the different type of the properties, that is it can use the adsorption, it can use the ion exchange process, it can use the size, it can use the charge, it can use the polarity. So on the base of that, you can have the different separation processes or different chromatographic techniques. Second thing is that you can classify the chromatographic techniques on the basis of mode of operation, whether you are separating the components on the plane surface or you are separating the components on a column. So you can have a planar chromatography or you can have a column chromatography. Similarly, you can have the different ways by which you can bring out the separation. That is, you can have an elution method, you can have a displacement method, or you can have other methods by which you can bring out the separation. So we can go into these one by one, but as I told, that classification may be different because of the different ways we bring out the chromatographic separation. So this is a general view, or that is on the type of mobile and stationary phase we classify the chromatographic techniques. So you can start from here, that is you have the mobile phase, that can be gas, that can be supercritical fluid, that can be liquid, or this is an electrophoresis, is also can be talked about a chromatographic technique, but for the time being, I said we have a gas, we have a supercritical fluid, and we have a liquid. So this is a mobile phase. Then the stationary phase. If we have a stationary phase liquid and you have a configuration, that is you are doing a chromatography on a column, then we call it as a gas liquid chromatography. Now, if you have a stationary phase that is a solid, now this solid stationary phase can be an adsorbent, simple adsorbent, or it can be a molecular seal. Now, if you bring out the separation of the column, again, this is called as gas solid chromatography. Now, you have a mobile phase here. In second case, it is a supercritical fluid. If the separation is on, if you are using the stationary phase liquid, You can use also the stationary phase, that is solid, but you bring out the separation on the column. This is called as supercritical fluid chromatography. Now, this one is important, that you have a mobile phase liquid, then a stationary phase can be liquid. This is called as liquid-liquid chromatography, or you can use this liquid on a column, or you can use it on a plane. So you have thin layer chromatography. Then you have a stationary phase solid. अब अगर आपके पास जो है stationary phase solid है, और इसमें आपका जो stationary phase है, जो इसकी property adsorbent as adsorbent काम करता है, ये as an ion exchange resin काम करता है, ये as a molecular sieve काम करता है, ये काम करता है as a ligand काम करता है, ये bonded phase काम करता है. So all these things result in the different types of chromatography. That is, if there's a phenomenon of ion exchange, it is called as ion exchange chromatography. If there's a molecular sieve, it is called as size exclusion chromatography. If you have a ligand, again, the configuration is on column, it is called as affinity chromatography. Then you have again a column, it is called as bonded phase chromatography. So these are the different types of chromatographic techniques on the base of the type of mobile phase, on the base of type of stationary phase, on the base of configuration, and then you have the different names that are we given. Now, second is